Welcome everyone. Everyone's had their lunch nice and warm in the tummy, hopefully, ready to go. What we're going to talk about today is database freedom and migrating to the cloud for native relational databases. So, my name is Blair Layton. I have been working with AWS for 5 years. In that period of time, I have seen huge change in how databases are being consumed on AWS, the type of applications, and we're going to go through some of that of what's actually happening in the market today and why people are looking to do the migrations, as well as how you actually go and do the migrations to AWS. So, the first thing is that the database market itself is changing. If we were to look at a history of databases, and this slide has got, it's a bit fuzzy, so bear with me, but on the left-hand side, you're starting from how people stored data originally, which was punch cards. So when I went to kindergarten, I actually had punch cards that I had to scribble on. You could see all the holes from what the computers had to read and everything, so that was quite amusing. And then we evolved to magnetic tape, and then obviously to files on disk, and then started the database side of things with Codicil and network databases. And then what you can see in the middle is in about the 1970s, we started to get the relational database. So the first one there is System R, and then you've got Oracle version 2. Now, Oracle version 2, apparently Larry Ellison didn't believe a version 1 would actually sell, so he just called version 1 version 2. And then after that, you've got all of the relational databases that you would probably know and love today. So Infomix, Sybase, SQL Server, etc. And then the open source versions that came out for Postgres and MySQL. And then what has happened, that is from 1970 up until the mid-2000s, a stable relational story. And then there was an explosion of databases that have come out over the last 10 years or so. And these are databases like Cassandra, React, our own DynamoDB, MongoDB, and so on, that are now giving you a huge choice of how you can actually deploy databases for your applications. So, looking at how people do traditional applications today, what are the types of things that you would typically do? Well, you would have a client tier, an application tier, and then a database tier. And in that database, you would say, we're going to put everything in there, right? Doesn't matter what it is, it's going to be the Swiss Army knife with all of these different data points in there, whether it's key value, whether it's log files, transactions, analytics, anything goes in that relational database. That was the mantra of how you built applications. What we're saying is that there's a better way of doing that. And what you want to be able to do is say, right, well, this is clearly a caching use case, or this is a NoSQL use case. I'm going to use a specific database to solve that specific component or part of the application. So that means if you want to do logging, then don't put that data in the database, put that into something like our S3 service. If you're going to do searching, don't expect the relational system to do that, put that into something like Elasticsearch. And if you're going to do caching, put that into something like Redis running on our managed service Elasticache. So really try and architect your applications to use the right data store for the particular job. So what are the databases that we have on offer, or data stores, that you can use to build your applications? Well, the first one here is on the relational side. We have Amazon Aurora and Amazon RDS. And inside that managed service, we have different flavors. So Aurora supports MySQL and Postgres. And then on RDS, we have MySQL and Postgres Community Edition. We have Oracle, SQL Server, and MariaDB as well. So those are all part of that particular managed service. Then when you move to key value data, the next one is DynamoDB. So this is a huge scalable, highly available, highly durable database operating in a NoSQL way where you can do key value data. And then for document, we also support JSON documents in DynamoDB as well. And then on the next one, we have a database in preview called Neptune, which allows you to actually have a graphing model for storing your data. So this is very good when you have very complex relationships and data associated with those relationships. If you're thinking in a relational model, when you have a kind of clear-cut case for a graph database, if you're doing complex joins on the same table, with other bit tables as well, and you're constantly referencing that same object and doing circular references, that's kind of telling you that there's a graph type of relationship there. Then if you're looking for in-memory operations, we have Elasticache, which supports Memcache and Redis. And then finally, on the right-hand side for search, we have Amazon's own Elasticsearch service. So these are all managed services in our database portfolio that you can build solutions with today. So that's the database market is changing, right? From that singular database in the relational world to be able to use all these different databases for your application. Now, what's also changing is application architecture. So what's actually happening? This is a kind of ball of crazy stuff that looks kind of scary, like something out of Star Wars that's going to come and kill you. But what it is a visualization of Amazon.com's microservices. So Amazon itself and AWS, we depend on building microservices. So what are they? Well, it's based on the service-oriented architecture concept, and you connect to this through simple APIs over HTTPS. And it's a single purpose. What this actual microservice does is it lives and breathes to deliver a particular service. And then you connect all of those up to build applications, which is what this big blob looks like. So if you're thinking about what you do today and how this has evolved, is you probably still have many monolithic applications. And when you take those monolithic applications and you split them up into SOA, which is what has been around, since the 2000s, if you liked, then that was kind of coarse-grained. But microservices take that to the next level, where we're really getting down to fine-grained services and pulling all of those together to create applications. Now, when you move to microservices, you will see some people talk about there's a couple of things that are really foundational ideas around them. One is that you should have a polyglot ecosystem. That is, for each microservice, you should decide what is the best technology for that particular microservice. You could even use mixtures of technology inside that microservice, whereas traditionally, people have standardized on, say, a Java and an Oracle stack or a .NET and SQL Server stack. Now, for each microservice, you can use what's the right data store for that particular microservice. And indeed, for a given microservice, you may have multiple data stores to deliver that particular service. Now, that doesn't lend itself very well to commercial databases, because what's going to happen is if you split your application up and you have all these different databases, you're going to have a licensing cost blowout. So what we're tending to find is that customers are now saying, when we move to microservices, we want to move to open source data stores. Then database market is changing, the application architecture is changing, the cloud adoption is also increasing. So when I joined AWS, this was what was happening back in 2013. We had gaming customers, phone apps, web CMS, e-commerce, and a little bit of business, but that was the bulk of what I saw. But things changed over time. So we have introduced the database migration service to help you migrate your databases without much downtime. So, a couple of minutes downtime from moving from on-prem into AWS. Aurora MySQL compatible edition and Postgres compatible edition. These are taking the open source engines and essentially giving them an enterprise experience for you, improve scalability, availability, durability, and support. And then performance insights. If you've looked at the open source databases, you will realize that the tooling is not as mature as, say, with Oracle Database or SQL Server. And that's definitely a fact of life, so we're trying to address that by providing a good monitoring service. And then we go down, there's incremental services for RDS SQL Server and Oracle, including a really good one across the platform, which is stop-start. So you can actually say, hey, I want this database in a dev test environment, but at night I want to stop it, and in the morning I'm going to start it. And then we introduced 16 terabytes of storage recently as well. So when you put all of these things together, that means that there's a lot more workloads that are business critical that are now coming in to AWS. Whether it's ERP, people running SAP on HANA or on Oracle, Oracle e-business suite, PeopleSoft, etc. And then things like marketing systems, accounting systems, etc. are all running on AWS today. Things that, back in 2013, you'd have conversations with people and they say, oh, that's never moving to the cloud. Well, they are now. They're all running there. But there are some things that are still not available and we can't do on AWS. So for example, if you said to me, hey, I've got this super duper powerful mainframe application, can I move that into AWS today? Going to lift and shift just as it is? Absolutely not, right? Because the scale of that server and what it can do is superior to a single server of what we can do on AWS. Now, if you want to re-architect it, then move to microservices, then we can talk. But there are some fundamental limitations about throughput and performance that we publicly disclose in terms of maximum size of our servers, vCPUs, etc. on our website. So when you combine all of this, right, the database market is changing, the application architecture is changing, and cloud adoption is increasing, the concept of database freedom is now gaining more traction. And especially when you're looking at how you're doing your databases today. Are you in this old world model where you've got very expensive software, it's proprietary, you get locked into that, then there's punitive licensing. So just back in February, I was here in India. We were doing a whiteboarding session in Bangalore for the customer, and we had a customer using SQL Server, and we were not able to provide the best architecture that we wanted to them because of the constraint on the number of licenses that they had for SQL Server, because we wanted to make it highly available and scale to their needs. Whereas if they were on an open source database, we could have just architected it exactly how we wanted it. So there was a lot of lock-in and lack of freedom from the way that these things are licensed. And of course, if you don't tend to buy something from one of the vendors for a year, you may end up with an audit so they can get some money out of you. And that's no fun for anybody. So then people might be saying, well, okay, but you know, what's going on? Hey, Blair's talking about all of these databases and how you can do great stuff on AWS, but AWS isn't really renowned for being a database company. Well, here you can see a Gartner Magic Quadrant. This is from November 2017. And up the top there, you've got Microsoft, Oracle, Amazon Web Services, SAP, and IBM. So Gartner is recognizing that across the database market, this is not just cloud, this is actually across the whole database market, that Amazon Web Services is a leader in this market. And when we move to cloud-based databases as a service, then you can see that AWS is out in front there based on this Forrester report that was done in Q2 last year. Now, you're going to say, well, are people actually doing this? And yes, they are. So Trimble has a logistics company which monitors fleets of vehicles, and they had an application that was running in Oracle, and they were able to use our tools, which we're going to talk a bit more about later, to migrate that into AWS. And there's a video which is here, which you can actually find on our YouTube channel, and they actually go through how they found out about how to do this migration and how the tools help them do that. So they thought it was going to be quite a complex and manual task, but when they looked at our tools and what we could do to help them with the migration, they found out it wasn't that complex as they had originally investigated and thought it would be. So then how do you migrate your databases to AWS? Well, the first thing that customers come in and they say, yep, we really want to migrate, but we can't afford long downtime. And then if we're going to try and keep the application running while we're doing the migration, the tools to do that are really quite expensive. So then it gets too complex and expensive to do the migration. And then they say, yeah, but if we do move, we still like a copy of the data on premise. And then, well, if we're going to move, we probably want to migrate to open source anyway, so that's going to be complex too. And then sending large volumes of data over a network, and especially if you're, say, somewhere like Thailand and you want to use the Singapore region, that's an international link, which can be quite expensive. And then finally, the last one is the skills. We don't have the skills to do that. So how do we address that? Well, first of all, you're going to say, okay, well, let's see how we would do this. You create your AWS account. Then you would set up your virtual private cloud, so that's all secure. You connect to AWS via a VPN or direct connect. Then you've got to shut down your database, back it up, and then you're going to send that into AWS, restore that environment on EC2, and then once you've got everything restored, you're going to configure your application environment and then get your users ready to go. Now the problem with that is, that step 4 to 9, that could take you a week or more. So you can't just go in and say, hey, that production system which is earning us money over there, let's just shut that down for a week and move to the cloud. That'll be cool, right? What we want to do is have a better way of doing this. So we've got the AWS Database Migration Service. Now this is a unfortunately terribly named product. What you should remember from this is the data migration service. So this is all about moving data between these databases. Now some of them are sources and some of them are targets. So for example, with MongoDB, that is a source and not a target. With DynamoDB, that is a target and not a source. So there's a couple of things around that, but the bulk of them, Postgres, Oracle, MySQL, SQL Server, MariaDB, etc., are sources and targets that you can move data around with that. We also have the schema conversion tool. So remember I said the database migration service was about moving the data. Well, then what we're going to do is we're going to have to actually migrate the schema. Because if you just use the database migration service, yeah, it might even create the tables and the primary keys, but it's not going to do the triggers, the store procedures, it's not going to convert the constraints and all those types of things. So this tool is what does the hard work of even trading, say, Oracle PL SQL to Postgres PL PG SQL. So this is really going to convert the whole schema. And not only that, it does data warehouses as well. So now when the data warehouse, it will actually provide extraction scripts to take that data out, put that into either Snowball or to a file system that you can then load into Redshift as part of this. And one hidden secret is that it actually does code migration as well. So now you've got these two tools, what you want to do is have a process of doing this. So remember, first step is use the schema conversion tool to actually take the source database, and you can either copy, so you could take a SQL Server database and copy that schema and create another SQL Server database, or convert, say, from SQL Server to MySQL using the schema conversion tool. At that point, that destination database just has a schema, no data. So the next step is we're going to move the data either with the database migration service for normal transactional databases, but for bigger actual data warehouses, we can use the schema conversion tool to do the unload and load process as well. This is probably the most important slide. Many customers get this wrong. They think that, hey, the database migration service, that's what it says on the tin, let's use that, and then they forget to use the schema conversion tool. So please remember that this is the actual process. So how does DMS work? You've got on your left-hand side here a source database running on-premise today. On the right-hand side, you've got AWS with your nice empty database already created by the schema conversion tool. You've got a VPN, and you've got your application users connecting to the original environment. What we're going to do now is we're going to actually create a replication instance. So this is what DMS runs on. And then we're going to connect the source and the target. Once we've connected the source and the target, then we need to select the tables, the schemas, or perhaps the whole database to migrate across. And once we've done that, then we're going to populate that database. This is going to happen while your application is still running on-premise. And now at this point, everything is basically caught up. You're going to have to suspend activity on the primary system, wait, make sure everything's caught up on the other side, which should hopefully only be a few seconds, and then you simply flip your environment over to AWS. So now we've gone from a process that, yes, is reasonably intensive. It's going to take you a while to set that up and get that going, probably a week or so. But the actual downtime for the application has moved from a week to hopefully no more than a couple of minutes. And this is really impressive for less than $10 per terabyte. So if you've looked at other tools that can do this type of migration of using change data capture, you will see that this is very cost effective to be able to do this. Now, this is just a guideline. We actually charge by the hour, but it's just saying, well, if you've got a database that's about a terabyte, it's going to cost you less than $10 to actually do a migration of that. So back to the schema conversion tool. Remember, this is what's going to change all of the synonyms, store procedures, etc. And this is what it looks like. So on the left-hand side here, you've got your representation. In this case is actually Oracle. And then in the right-hand side, you've got your target, which in this case is MySQL. Here you have a store procedure, and this is the Oracle one. And then over here is the MySQL equivalent. And in the middle at the top are the problems that we found. And then you can go through and edit this and create a fresh schema with everything ready to go. And this is all happening inside the tool. It's not going to be propagated out to the target database until you actually select the option to push that out either to the target database directly or to create actual SQL statements in DDL files that you can then run on the target database. So this is the most important thing if you're going to say, right, I really want to have a look at how to do a database migration, but I have no idea how complicated it's going to be. Inside the schema conversion tool, there is a report that does an assessment, and you can run that by simply downloading the schema conversion tool onto your laptop or onto your desktop or even a server, pointing that to your source target, and then running this report. And the graphs that you can see there are telling you how many things in green are simply going to be migrated, some that require a little bit of work, and others that are going to require significant work. And we'll do that for both MySQL and Postgres. So let's say you've got an Oracle database, you run this report, and you can make a decision of, oh, it's not looking so good for MySQL, maybe we should go to Postgres for this database because it's going to be easier to do the migration. And that's typically what we tend to find with Oracle. There's a much tighter fit for migrating from Oracle to Postgres. So let's have a look at customer success. We've had more than 65,000 databases migrated with DMS to date. On here, you can see that there are different companies across different industries, and there's even one that's represented up here, Shadi.com, here in India. So Shadi.com migrated from MySQL to using Amazon Aurora, the MySQL compatible version. And they use the database migration service to move between those different databases into AWS with Amazon Aurora. They also saved money as part of that migration, and they estimated that the migration process was saved by about 40% in terms of time and effort based on using the tools that we had provided them. So this was a great success, and it's here locally in India. Other customers you can see are in telco. Globe is a telco in the Philippines. And then you've got Flipboard, which have used that on the phone, which is a personal magazine you can customize and so on. So many different customers using this for all sorts of different types of migrations. Now, if you're looking at how can you get started, what do you get the benefits of using database freedom with AWS? Well, innovation is key, right? That's what database freedom is fundamentally all about. So here, what have we got? We've got the database migration service, which is going to help you, and the schema conversion tool. Remember, on the database side of things, we've got Aurora MySQL, and we've got Aurora Postgres. And then we have, for RDS, all of the open source engines, plus the commercial engines of SQL Server and Oracle. On the NoSQL world, we've got DynamoDB, in front of DynamoDB, which is our NoSQL offering. Then we've got a cache called DAX, and that helps accelerate DynamoDB to give you even faster and better throughput. Then, if you're looking for analytics, we've got EMR to help you with the whole Hadoop ecosystem with Spark and so on. And then there's Redshift with Spectrum, which allows you to query a traditional data warehouse, but then take data and put that down into S3 so that you can actually query data directly from your local disk and then across S3 and scale that out to petabytes of data. And then there's plenty of other services in the database arena for you to take data once you've loaded it into AWS and do analysis around machine learning and AI as well. So, if you're looking at, okay, what else are we doing around innovation? Well, we're constantly pushing out new things around our platform. And we introduce new instances which are great for databases as well. There's a new instance type that we recently introduced called the X1E. This has a really high relationship between vCPUs and RAM. So if your database is super RAM dependent, but you don't need many cores, then this is the instance for you. So we can have, in this particular instance type, up to 4 terabytes of RAM with 128 virtual CPUs. And there was a new feature which was just released yesterday, and we're able to talk about it finally. And this is called Optimized CPU. What this feature allows you to do is actually take an instance type, let's say an R4 8XL. Now an R4 8XL has 32 virtual CPUs and 256 gigs of memory. But if you say, I actually need that memory, but I don't need that many vCPUs because I want to save on SQL Server or Oracle licensing. What you're now able to do is when you launch that instance is to say, I only want this instance with, say, 6 vCPUs, but I still need that 256 gig of RAM. That then allows you to launch and create essentially a custom instance type just by using this optimized CPU feature. It is literally just launching from the standard process of what we would normally do for launching an instance, but you're getting the ability to actually define the attributes of that. The other thing that we introduced with this feature is the capability to turn off hyperthreading. This is really important if you're bringing SQL Server workloads into AWS, because SQL Server is licensed by hardware threads or essentially the hyperthreading. Therefore, if we're turning off hyperthreading, we're saving costs there. So you can save costs by turning off hyperthreading and by launching an instance with the right number of vCPUs for what you need. So this is an excellent new feature that we've just introduced, and that shows you some of the innovation that we're constantly doing on our platform. Now, what about the expertise? Well, professional services are here to help you. And we have actually just recently acquired a company which has resources here in India. And if you go to the migration booth here at the summit, you can go and talk to them, and they have expertise in taking Oracle and SQL Server and other commercial databases to Postgres. And these are people that you can actually get from our professional services organization to come and help you do these types of migrations. But we also have partners who can do this for you too. So for example, there's another partner outside, BlazeClan, and they are very keen to help do database migrations and assist you with these types of migrations to AWS. And then the service teams. These are the people responsible for delivering the products that we talk about. They are there to help as well. And we especially have different people in India who have direct lines back to those service teams that when you need help, maybe you need a new feature or there's something that's not working correctly, we are more than happy to go right back to those service teams and help you resolve your problems and make sure you can do a migration. We do have a qualification framework. So if you run something like the schema conversion tool with the assessment report, then we have some questions and things that we can also ask you to help determine what is the best way forward for you. Let's say that you have 100 databases and associated applications. There's no way that you're going to be able to say, right, we'll just migrate those in the next week. Right? We're going to have to go through and look at the integration of those applications and data platforms, decide what is the direction that you want to move to. Are you going to move towards open source or not? Are you going to keep something, say, on Oracle and SQL Server? What's the licensing implications of that? How do we manage the strategy over, say, a 5-year migration plan if that's what is needed? All of these things are things that we need to ask questions about to make sure we have a good plan. And then we've got patterns and recommendations. So we just launched a different white paper, if you like. It's a playbook on how to migrate from Oracle to Postgres. And inside that playbook, you will see the Oracle feature and what that is, explaining how it works in Oracle, and then what the equivalent is in Postgres and how it works in Postgres. So that then gives you the confidence of how you're going to map some of these things as you do a migration. We also can do workshops. So if you want to learn how to use our tooling to do migrations, we can do a workshop for your company, or if there's a lot of demand in a particular city, we could do a one-to-many workshop for something like that. And then proof of concepts. We will help with funding, in terms of credits that we can give to you to do proof of concepts. We also can help with funding for partners to do proof of concepts with you and assist with the migration. And then we also have incentives for big programs, like if you're going to move out of a data center into AWS, we have a migration acceleration program where we can help with funding as part of that as well. So that gives you a good overview, I think, hopefully, of all of the tooling, then the processes and the support that we can put in place for doing a migration. Now, what I'm going to do now is hand the presentation over to Gautam, and he's going to come up and talk to you about his experience of actually using Amazon Aurora, which I've talked about a little bit, but he's going to talk about a lot more. Thank you very much.